All right, good morning. I'm trying to get my Zoom to stop making little dinging noises every time someone comes in the room, because people come in and leave all throughout class. And I'm getting dings stuck in my brain. All right, going to talk about ODPs, going to talk about writing bash scripts, and we're going to go back and dig into some C programs, look at the hello world in more detail, and so on. All right, so some chat questions. One question, for some reason there are two entries for my login ID when I use the who command. So if you get disconnected from the Linux server, your previous session does not always get closed out. And so this is something to keep an eye on. So let's log into the Linux server. So if I do a who, just looking for myself, I'm logged in once. It's possible that if, for example, my window just goes away, so let me make a new window. Oh yeah, hold on, let me share my screen. There we go, thank you. So I do a who and I'm logged in once, right? So it's possible that if my window goes away, if something happens and I just lose my connection and I log back in again, that previous session will still be around. So for me, it logged me out, but in some cases, your session will stick around for a while. Sometimes it will eventually time out. It's possible it will not. I think if you're generating output at the time, it may continue to run. So you can always kill yourself, right? You can say do a full process status on user Nick, and I can see all the places where I'm logged in. And if I have a bash shell that I want to get rid of, right, I could kill that just by saying kill and put in that PID, and that would kill me. If it doesn't, you can always say kill -9 PID. That's guaranteed to shut down your process. So that's one way to get rid of those stray processes if you're showing up more than once. And you can always send me an email and say I've got a stray process, and I can try to take care of that. But send me an email if you want me to look at that, because my chat windows go away after class ends. All right, how do you confirm the deletion of a directory in Linux? Just do an ls. If you don't see it, the directory is gone. Disabling the bell noise in Bash and Vim was essential when I started using SSH. Yeah, so you can set up those settings. You can set up a visual bell so the screen flashes instead of making a bell sound, or just turn off computer sounds on your operating system if you like. Hey Nick, can we see your screen? Yeah, I turn my screen on, thank you. What does grep mean? So grep is a search command. Grep lets you search for a string inside a file. So I can search for the keyword prompt inside my bash rc file, and there's all the lines of my file where the word prompt appears. So it's a basic search command, and you can put in things more complex than just a series of characters. It does what are called regular expressions, which we're going to spend a few days talking about later on in this course. But that's what the REP is for, regular expressions. You can always kill. Yeah, don't quote me when I said you can always kill yourself. I meant your process. Um, all right, cool. Let's see. Other questions? This is good. Lots of good chat questions. All right, so let's talk about ODP 406. So someone just commented in chat, I can't wait until we talk about sed and awk. Sed and awk are awesome. We'll spend about a week talking about those. Awk is my new favorite utility. I'm like using it for everything these days. These are tools for processing text files, basically, but really, really powerful tools. All of your automated grading, when I pull your grades down and I upload them into Canvas, it's a big awk, big script of awk commands, basically. Really powerful language for general purpose programming, but also for processing text files and such. All right, so ODP 406, we're supposed to read a number from the user and then print out that many pipes. So let's read the number. I'll make a counter. And that should do it. So we get a number from the user, we initialize a counter. While that counter is less than the number, we echo out the pipe. When I write while loops in bash, I always make this mistake. I forget to increment I. So if I run this and I say I want 3 pipes, I get like 3 zillion pipes. If you get output going crazy like this, don't use Control Z, use Control C. Okay, hold down Control, press a C. It might take a few seconds to kick in, but do a Control C. Don't do a Control Z. Control Z does not kill your process. Okay, it suspends it, but it leaves it in there in the background, taking up resources. Yeah, I saw that picture on Discord. I always make this mistake when I write shell scripts, especially first thing in the day. So in a while loop, right, we need to increment I, so I equals $I plus 1. Alright, so now if I ask for 5 pipes, I get 5 pipes and the number 5 in parentheses. If I ask for 1 pipe, I get that. If I ask for 212 pipes, I get 212 pipes. Alright, so this is your basic ODP. So as I pointed out in the announcements, made a few announcements on this yesterday, make sure you put the shebang in the beginning. Okay, always put that first line of your script, and it's got to be the first line. Okay, if you do something like this, right, this has no effect on how my script is executed. It's no longer considered a shebang, right? It's got to be the very first line, so you have to write it like this. All right, so make sure you have that in the very beginning. And then this is just straight bash code, right? The echo dash n we talked about yesterday. That's a way to output something but not automatically put the new line at the end. If you just say echo without a dash n, you do get a new line at the end, which is what we want. We wanted a row of pipes. We wanted your number in parentheses followed by a single new line. That's what echo will do. All right, make sure it's executable. Run it from your command line yourself. Make sure it looks like it's doing the right thing. Then go ahead and assess it. And I think most people got through this in the end, but it took multiple tries in some cases because it's bash. It's picky, right? All right, so Let me talk quickly about ODP 407, and then I want to make some general comments. So let's take a look at temp ODP 407. So for this one, you're writing a script which does multiple things, okay? First, it's going to print a number sign. That's the prompt. It's a single character. There's no space after it. There's no new line after it. Just a number sign, okay? And print that using an echo statement, echo-n. And then read a number from the user, okay? They'll type in a number. It should be an integer bigger than or equal to 1 or less than or equal to 4, and less than or equal to 4. Okay? If it is, print out 2 letters, OK, followed by a new line and exit. Otherwise, print out 3 letters, ERR, followed by a new line. Prompt them again with a single number sign. Read a number from the user. If it's bigger than or equal to 1 and less than or equal to 4, print OK. Otherwise, print fail and exit. Okay, so there's no looping in here. You can write this with a loop, but there's no repeated trying. You basically get one try after you've made a mistake. So this looks something like this. Right, there's my prompt. It's a number sign with nothing appearing after it. If I type in a valid number, it says OK. Here's another valid number, it says OK. Here's an illegal number, it says error. And it lets me try again. And if I come back with a valid answer, it says OK. If I put in an invalid number, it says error. If I put in an invalid number a second time, it says fail. All right, and that's the whole totality of what this program can do. So input a number if it's legal, okay. If it's illegal, input a number a second time. If it's legal, okay. Otherwise, fail. All right, and this is, obviously part of homework 3. This is part of your stick game. This is the logic that you're going to use when you ask the user, how many sticks would you like to take? Right, so they're going to type in a number, and you're going to see if it's legal, and if it's not, you'll give them one more chance, and so on and so forth. So this is the logic, right, of that part of your stick program, which we wrote some pseudocode for yesterday. We called it something like, ask how many sticks the user wants or something. The details are different, but the logic is going to be the same. So yeah, you can do this with nested if statements. You can do it without nesting if statements because we're exiting as soon as they put in their correct answer. So you could do it with a pair of if statements. You can do it with a loop. I've seen people do that, but it's a loop that at most is going to loop twice. Someone asked how many if statements is too many. I'm not going to put a hard and fast rule on it, but hopefully people are not trying to write code that's hard to read, right? There are contests for that, especially in languages like Perl, where the goal is to make the most difficult to read code for some simple task. So hopefully no one's doing that. But, if you feel like you need 3 if statements to do this, use 3 if statements. Okay, but I want it to make sense to you. Yeah, don't do a read-p. Use an echo-n, okay? Because for technical reasons, read-p does something different. If you want to know, read-p does not output to standard out. It outputs to standard error. All right, I should probably note that, All right, there you go. So we'll talk about standard out, standard error, standard in detail another time. But basically, standard error by default goes to your terminal. Okay, so if something comes out that's an error message, you see it on your screen just like if it comes out to regular standard out. But they're actually going through different conduits, and the assess program is written to look at standard out, right? It's looking at what is being generated by your script or your program to standard out, so the read-p doesn't get picked up, and it looks like you're not outputting the prompt correctly. It's a goofy glitch, but once we're done with bash, it will not come up. Assess is really written for C programs, and it works really well for C coding. I've got it kind of working with bash, but it's got a few quirks we have to deal with. Let's see, question, symbol for less than or equal to in bash. So if we're comparing numbers, yeah, you want to compare using -LT for less than, or -LE for less than or equal to. Right? Don't ever use the less than sign or the less than equal sign in doing comparisons of numbers. And this brings me to my next topic, okay? If you go back to I think week 1 when we started talking about bash, I posted this summary of bash statements, this how-to guide on Canvas, and right up here in the top in bold face there's a note here that says, in order to receive credit on assignments, homeworks, and tests, you need to use these constructs, okay? Now for ODPs, the ODPs are automatically graded. I look at the code if you're having trouble and I want to see what you're doing and try to give you some help, but I don't grade it manually, okay? So you could write something that works totally different. You could use all kinds of bizarre bash constructs. You could write this in C, you could write it in Ruby, right? As long as it's generating the correct response in response to inputs, right? ODP will give you 100% on it. That's okay, but when you get to your stick program, homework 3, when you turn things in on the midterm and on the final and stuff, I gotta see while loops written exactly like this. Okay, exactly this format. I've got to see comparisons done exactly like this or that. I've got to see if statements done exactly like this. Okay, and the ODPs are really a chance to practice that. The ODPs are designed to give you a chance to get better at working with bash, to pin down your understanding of writing bash scripts and so on. So the way that you write your bash code is going to be really critical, right? The ODPs will let you get away with it, but that's kind of a false sense of security, because if the only time you've written while loops is using single square brackets or parentheses or less than signs instead of -LT, and then you get to the midterm and you do the same thing, you get a 0 on those questions, right? And if you come to me and you say, hey, this works, why didn't I get credit? I'm going to point you back to here. Okay, so please, please, please make sure that that you're following this guide. Okay. Let's see, comment, I've already finished my homework 3, made sure to always use double square brackets. Some of my statements are different. It depends on how your statements are different. So if you want, send me an email and show me your code and tell me what you're concerned about, and I'll tell you if you need to rewrite it or not. Okay? That's to the person in chat who just asked me about that. Don't do that Thursday night, everybody in the class. Don't send me your code and say, does this look good? All right, so that's something to keep in mind, right? And as I say, the ODPs will let you get away with a lot, but try to do your code the way that it's described in this document. Let me know if you have questions on that. How do you want us to do for loops? I don't want you to do for loops. So if you need to do a for loop, write it as a while loop. The reason being, for loops are kind of wonky. They need double parentheses, and then it's just an invitation to get confused between double parentheses and double brackets and so on. So write your for loops with a while loop with an increment at the bottom. All right, one more time, let me talk about getting help on these assignments, because I sent this to so many people individually, one by one, yesterday and last night. If you're having trouble with an ODP, a programming assignment, something like that, and you want to show me your code, we've talked about this. There's a video posted. It's like the second or third video on the CSE channel on YouTube for how to get help on these things. So let's go through this one more time. You've got an ODP and it's not working, right? So here's my ODP 406, and I'm going to I don't know, I'll do something like that. And I'll try to assess this, and I'll grade it, and I get 0 out of 10 on all of these. And you send me an email and say, you know, my ODP works perfectly, here's the code, okay? If you send me a screenshot, if you send me an attachment, if you send me a link to a virtual drive somewhere in the cloud, right? These are really hard things for me to work with, okay? If I want to sit down and that's what I want to do for the next N minutes, I can obviously get to your code, okay? But multiply that by 20 or 30 or 50, and if it's going to take me 5 minutes to get to your code, that's, you know, 4 or 5 hours that I'm going to spend trying to answer student questions. Try to make it easy for me. That will make it more efficient for you, okay? So I've described exactly how I would like you to ask for help on these, not just so I can read it more easily, but so I can understand what you're doing. So let's say you're trying to assess your code, right? You know, open a new window or start with a clean screen or something like that. Show me your directory, show me the date, show me your code. If it's a C program, show me how you're compiling it. Put in the GCC command. Show me your tests. Show me some more tests. Show me your assessment. Okay, once you've got all of that done, go back to the start of all of this, copy your experience, okay? PuTTY, you can set it to just highlight to copy. Console, you can set it to just highlight to copy. Do something so that you can you know, take all of this stuff, throw it on the clipboard, okay? Go into your mail program or go into an editor, right? Find yourself a monospaced font, right? Like Roboto Mono. I'm using Google Docs here just for an example because I don't want to bring up my mailer program. Paste it as plain text into the email, okay? Control Shift V or Control V will usually do that. I just did it a whole bunch of times. All right. So I've got my full script of what I've been doing, right? And send that to me as an email, right? Don't make it an attachment. Don't send me a screenshot. Don't put a link to it, right? Paste this into your mail program in a message to me, to my Clark email, not my Canvas email, okay? I'm not just being picky here, okay? There are reasons for each of these things that I'm saying. If you send it to my Canvas email, I can only look at it on certain devices, and sometimes replies get lost, okay? If you make this an attachment, I have to download it, and you know, it may get sucked up by an antivirus program because Clark runs these antivirus scanners. So plain text, right? And then I can look at this, and I can look at your code and see that's correct, and I can come down here and say, hey, you assessed it at a time when ODP 407 was running, even though your code was for ODP 406. When did you do that? Oh, you did it at 10 o'clock on Tuesday. Yeah, ODP 406 had already closed, right? Just looking at your code, I'm not going to be able to tell you that. So the more information you can give me, the better, okay? So that's just kind of an example of you know, what might be more successful in trying to get help if things aren't working the way you think they should be. All right, so any other questions on any of that? All right, so let's go back to looking at our Hello World program. We started looking at this yesterday. So 5-line program, 2 lines are curly brackets, so really 3 lines of code. And we started digging into this include statement. Okay, and we said that when you say include, it basically reads the contents of a file and replaces this include statement with the contents of that file. Okay. So stdio is this 1,000-line program. It's a bunch of what we call preprocessor directives, includes, defines, conditional if statements, and so on. All of that gets glommed into your program right here, where this highlighted line is. And then that big long program, which now has, thousands of extra lines of code in it, that gets compiled. Okay. But it's really the C preprocessor that is taking care of those include statements. And you can play with the C preprocessor. So let me run the C preprocessor on hello.c and put that output in a file called test. And if I look at test, right, this is the file that's basically getting compiled. There's tags in here, indicating where it is in its process. But all of this stuff is now part of my C program. Okay, it didn't change hello.c, but this is what's being passed to the compiler to compile. And so among other things, there's a declaration of the printf function. So that when I say printf hello world, it knows printf is a function, it returns an integer, it's declared outside of this file, it expects these kinds of arguments. All right, and we looked at the compiled image yesterday, and we saw lots of computer readable, non-human readable content, and we talked about ways to examine the binary file in more detail. Let's talk about integer main. All right, so first of all, why do we call it main? Because if we call it mmain, it will still compile, but we don't get an executable program. And we get this message down here, undefined reference to main. Okay, this is technically not a compile error. The program itself is valid C code. There's no reason we can't have a function called mmain that does a printf, right? So this is fine C code. This is actually a problem with linking. So when we do C, right, we have source code, which is a .c file, that actually goes through a preprocessor, which basically generates C code. That goes through a compiler, which generates an object. And an object is a compiled version of C. It's still binary, it's ones and zeros, but it's not quite ready to execute. But an object gets linked with other things like the runtime library or other files that we've written to create an executable. And then this is the ones and zeros that actually run on our CPU. To make an executable, you have to have a function named main. That's just the rule, right? The linker is going to look for a function named main, and it's going to build your executable so that when you type in the name of this file, it starts executing the first line of whatever function was named main. Well, if you don't have a function named main, the linker will actually complain. So this message, collect2: that's coming from the linker. And it's saying you don't have a main, right? So LD, that's the loader. The load program is how we do the linking. So that's just the rules of C, right? You have to have a program named main. Now I can do this. And that's perfectly fine. See, I have two functions. One is called mmain, which prints haha. The other is called main, which prints hello. Nothing wrong with that. And when you run this, it's the main program, which printed hello, right, which we see executing. So that's just a thing, right? Technically, you can call functions anything that you want. You can have or not have any functions that you choose. But if you're trying to build an executable program, there has to be exactly one main program. All right. We'll talk about arguments in a few days, but normally, you know, when you write a main program, you have this integer argc, comma, char star star argv. We're not going to worry about those today. But let's talk about this integer, this return value, right? When you put int in front of a function, it means that function is supposed to return an integer. Well, C is usually pretty forgiving. If I don't specify, you know, return some number, it'll just kind of fall off the end of the world. It will go back to whoever called it, and things will work fine. But because we're saying this is a function that returns an integer, right, I can actually specify an integer that I want to return. So I can compile that, I can run my hello program, and there's a hello. Well, I never saw my 42. Right? It says it should return 42. I run hello, I just see the word hello, you know, my message come out. Where does that 42 go? Well, I didn't say print 42. I said return it. That's the value of the function. If I had said x equals main, now x would be equal to 42. Okay, but from the shell, I just type in the name of the executable program, it executes, and that 42 gets returned to bash. All right, but it turns out we can get a hold of that value. So there's another variable, I don't know if we've talked about it or not, but this variable $?, which you generally use to tell if a command succeeded or not. Usually after a command, if you check this, if it's equal to 0, your command succeeded. If it's non-zero, it failed. But this is actually the return value from the main program of the command you just executed. So if I echo $?, there's my 42. And if I echo it again, it's a 0. Why? Because now I'm looking at the return value from this echo statement. And the echo statement, you know, ran successfully, so the main program of the command called echo returns a 0. And that's what I'm seeing here. If I run hello, and I make a typo when I try to echo $?, and then I fix that and I echo $?, I don't get my 42. I'm getting the return code from my prior command, which was this. Right? And this was an unknown command, and so bash set my return status to 127. Right? So you can pick up return values from C programs, but it has to be the very next thing you do is you check the value of $?. And if you want to use that later, you know, save it somewhere. So hello status equals $?, haha. So I can say return value was $status, there's my 42. Right, I've saved it somewhere. All right, so integer main is saying it's going to return an integer value. If we put a return statement, we can specify what that value will be. If not, then we should treat it as undefined. Generally, it's going to be a 0, but I don't think that's guaranteed. All right, so the last piece of our program is this printf statement. And we already said printf is a function that's defined inside standardIO.h. That's where it's prototyped. And printf is not a function that we wrote. It's a function that's linked in by GCC when we compile this program. So if I want to use a square root function, I can set f equal to the square root of f, right, where f is a double. And I can include math.h to prototype the square root function. And here again, when I try to compile my program, the compile works fine. But when I try to link, when I call the ld command, it says undefined reference to square root. So when I try to write a program that uses printf and I compile that with GCC, it works fine. It knows where to find printf because everybody uses printf. Everybody uses scanf and fgets and so on. So those are part of sort of the standard C runtime library. But square root is not part of that standard set of functions that get linked into our main program. So I have to tell it where to find square root. So this is why when you compile something like this, you have to say -lm. That says look for a library called, well, we specify an m, it's actually libm, and it's in a particular directory. So if I do that, then it can link in the square root function. So this printf function is actually a function call to something that's not written by us, but it's in another library. And GCC will find that, and it will link things together so that when the executable created by GCC executes, this is a function call. It's a call to printf. So we'll do a quick preview here. So I'm going to compile, but I'm going to put in this -g switch, which says, give me some debugger information. And I'm going to run a command called gdb. We're going to spend a lot of time talking about gdb. gdb is a debugger. And inside gdb, I can see my program. I can see that I'm about to execute a print statement. And if I say, examine/i PC, I'm about to move this value into this register, and I'm about to call this location, which is something called puts. Okay, this is how it's going to execute the print statement. If I look at this location, presumably I find the word hello followed by a new line and an all terminator, and it's not even calling printf, it's calling puts, right? Printf is nice when you have an integer and you want to convert it from an integer to a set of characters, so you use a %d format and all of that. That's when printf comes in. But the compiler knows all I'm doing is printing a fixed string. It doesn't need the heavy power of printf. It can get away with just puts. So it actually wrote assembly language code to say, let's just call puts. And this location, I don't know if I know how to force it into character mode, right? If I look at this address, I find the number 72, which is the letter H, followed by ELLO, new line, or exclamation mark, new line, terminator. Because puts a new line on the end automatically. So there's the thing that's being sent to the puts function, right? So this code at this location, that's the put function. That's not something that I wrote, right? This is code that is part of the C runtime library. So that's part of what GCC is doing, is linking pieces together. So this printf is something pretty heavy going on. But the bottom line is, right, it calls some pre-existing code which will take this string of characters and cause it to appear on, in this case, my display, but technically on standard out. And yeah, if you've had Engineering 270, this is probably triggering some memories, good or bad. All right. I just want to comment on a comment someone made a while ago in chat about object files. If you have multiple C files, you can compile them to object files, and you don't need to change the code. In some of these files, you can recompile them and just link them. So this is something else we're going to talk about when we discuss makefiles. But this whole process of taking a program that's a C file and turning it into an executable, that's the most straightforward way to build a runnable program. Just GCC sourcefile.c -o executable name. But a lot of times we'll have multiple source files that all get combined into an executable. So this is just a preamble to talking about makefiles. So here's file 1.c. Here's file 2.c, here's file 3.c. So really we're going to compile each of these to an object. And then these are going to get linked together into, you know, some executable program that I'll just call main. Now if we just say gcc-o main f1.c, f2.c, f3.c, then every time that we build our main program, this gets compiled, that gets compiled, and these three get linked. But in reality, if the only thing we're changing is file 2, all we need to do is recompile file 2 and then relink these three objects. And ultimately, that's what we're going to want to do when we develop code. If our code is split out into three different files, and one of those files change, we don't need to recompile those other files. So we're going to keep these object files around. We're going to compile each C program to an object file and then link those together. And then, you know, if we decide we need to make a change to file 1, we'll recompile file 1, but we don't need to recompile file 2 and 3. We recompile file 1, we relink all three of these, and we get our main program. And the thing is, linking is inexpensive. Compiling is relatively expensive. And if you have 1,000 C files that get built together into a single main, and you change one of those files, you don't want to recompile the other 999 files. So when we talk about makefiles, this will be the idea we're working with, is trying to do sort of incremental compilation and not rebuilding the whole thing from scratch every time that we want to make a new file. All right, so that's sort of like really digging down deep into, you know, what's essentially a pretty simple, basically a 3-line program. Right, so our basic hello world. And we don't necessarily need to get too caught up on that right now, but in CSE222, we'll be going pretty low level with C. We're going to be working with, you know, manipulating memory directly and things like that. And so being able to think about what's going on at the hardware level of this kind of thing is going to be really useful. All right, so any questions about that? All right, we have a few minutes left. So I want to talk about VI, and we'll mostly do this tomorrow, but let me tell you why I want to talk about VI. As I've said before, you want to try to be efficient when you're working on programming, right? If you're trying to get an ODP to run, or you're trying to make your stick picking game, you want to be able to spend your energy working on the algorithm, working on the code, debugging the code, that kind of thing. You don't want to be spending a lot of time or energy trying to actually enter the code into the computer, right? And if you're using Notepad, if you're using gedit or mousepad or Kate or these kinds of tools, you're spending a lot of time moving around using arrow keys, scrolling around using the mouse, dragging the mouse over characters to select them and cut them and then paste them somewhere else. That's not where you want to be spending your time. Okay, you want to be spending your time thinking about the algorithm, looking at the code, figuring out where the bugs are, coming up with test cases, changing codes to implement test cases, running those, analyzing the output, tweaking your code, recompiling. You want to be doing this. You're going to be doing this for hours sometimes, right? The more efficient you are at doing that, not only the quicker you get through the process, but the more intensely you can get immersed in that process, right? And a lot of this coding and development and debugging especially really needs you to get your head inside the problem, okay? And every time you come out of that, it sets you back a bunch of steps. So you want to get your head into your code, and you want to just be you in the code. And here's an idea, and I'm going to put this in, I'm going to run it, and here's what happened. Okay, so I'm going to put that with the 5 things that I discovered 25 steps ago, and I'm going to try something new, right? And coming out of that to find your mouse and scroll back to some older section of code and try to select this word, and I mean, that's not where you want to be. All right, so VI is one of a number of editors that you can be very efficient in. Nice thing about VI, you never have to use your mouse. Okay, and if you use VI the way that it was really meant to be used, it's super efficient. Unfortunately, most people who come to VI use it the way they would use Notepad. They move up and down and left and right with the arrow keys. They delete by going in front of the characters that they want to get rid of and backspacing to delete them, right? And they copy and paste using the mouse. And that's not what VI was meant for. So I want to spend some time tomorrow basically running through the basics of VI and a few tricks to sort of help you use VI more efficiently, hopefully. There's a short video I posted on the channel that goes through a lot of what I'm going to talk about, but we'll go through this tomorrow, okay? And then we'll start digging into C on Thursday and some more ODPs. All right, I will see you next time. Have a great afternoon.